Good morning. How's everyone doing this morning? It is so exciting to be back here in San Francisco with so many of our press and analysts and partners and friends in the audience. And welcome to all of you who are joining us across the world. We have a lot of new products and exciting news to share with you today, so let's go ahead and get started. Today, we're here to talk about our newest EPYC data center processors, our upcoming Instinct accelerators, and our growing AI software ecosystem. Since launching EPYC in 2017, we have been laser-focused on building the industry's best data center CPUs. EPYC is now the industry standard in the cloud. And that momentum is just growing as we ramp our 4th-gen EPYC Genoa processors. Genoa is the best CPU for AI. The best way to look at AI performance is actually to look at a broad set of end-to-end workloads. And so we use the industry standard TPC-XA benchmark that actually looks at end-to-end AI performance across 10 different use cases and a host of different algorithms. And what we see in this case is EPYC is 1.9 times more performant than the competition. Please welcome our good friend, AWS Vice President Dave Brown. Dave.
Hey, Lisa.
It is so wonderful to see you. Thank you so much for being here with us today.
Great to see you as well. Thank you.
Can you talk a little bit about our partnership?
Absolutely, Lisa. And thank you for having me, and thank you for the opportunity of being here today. I'm excited to talk about our partnership and how AWS and AMD are continuing to collaborate to advance cloud technology for our customers. Together, we have introduced over 100 AMD EPYC-based Amazon EC2 instances for general-purpose, compute-intensive, and memory-intensive workloads.
Now, we always talk about what can we do with our joint customers, and how do they benefit from our technology? So can you tell us a little bit about customers?
A few examples of how enterprise customers have invested these cost savings into innovation to improve their businesses include TrueCar, a digital automotive marketplace, one of my favorite tools. They sought ways to operate more efficiently and increase development velocity so they could invest the money saved into innovating for car buying experience. And TrueCar optimized its AWS Cloud infrastructure by up to 25% from a combination of choosing the AMD Instance family for its core infrastructure, as well as right-sizing instances with AWS recommendation tools. And then in the HPC space, DTN, they run weather and data models that deliver sophisticated, high-resolution outputs that require continuous processing for vast amounts of data from inputs across the globe. DTN uses Amazon EC2's HPC 6A instances, powered by AMD's EPYC processors, to run computer-intensive HPC workloads.
Can you talk a little bit about what's next for our partnership?
Absolutely, Lisa. To help address customer needs, we're building new EC2 instances enabled by the unique combination of the 4th-generation AMD EPYC processors together with the AWS Nitro system.
Let's talk about what that means for customers.
Well, today, we are very excited to announce the preview of Amazon EC2 M7A general-purpose instances powered by the 4th-generation AMD EPYC processor. And based on our spec...
They're kind of excited about that,
So are we.
Yeah.
And based on our spec-int benchmarks, M7A has been designed to provide the best x86 performance and price performance per vCPU within the Amazon EC2 x86 general-purpose instance family. M7A instances offer a major leap in performance with up to 50% more compute performance than M6A, the previous generation. Lisa, we're also very excited that AMD will be using these instances for your own workloads.
Yeah, absolutely, Dave. By the way, did you guys hear that he said 50% more compute performance on M7A? It's just amazing gen-on-gen performance, and we're so excited that we're going to see Genoa throughout EC2. Oracle is announcing today also new Genoa standard, HPC, and dense I/O instances that are expected to enter general production starting in July. Now let's talk about cloud-native computing. Bergamo is actually our first EPYC processor designed specifically for cloud workloads. Bergamo leverages all of the platform infrastructure that we already developed for Genoa, and it supports the same next-gen memory and the same I/O capabilities, but it allows us, with this design point, to expand to 128 cores per socket for leadership performance and energy efficiency in the cloud. I am very happy to show you Bergamo. This is our new cloud-native processor, and what we have here is there's actually a new compute die. So the compute die is different from Genoa, using our triplet technology. Each of these 8 compute dies has 16 of our Zen 4 cores, and then we use the same 6-nanometer I/O die used by Genoa in the center. From a product standpoint, what does this mean? What it means is the only real difference between Genoa and Bergamo is the CCD core chiplet. So we use the same socket, we swap out the Genoa CPU chiplet, and we put in the Bergamo CPU chiplet. And what you have is each of the 8 compute chiplets on Bergamo contains twice the number of cores as was on Genoa. And that's how we get to 128 cores per socket. But importantly, as I said, it's fully software compatible, and it's also fully platform compatible with Genoa. If you compare Bergamo to our competition's top of stack, what you'll see is just incredible performance. We're delivering up to 2.6 times more performance across a wide range of cloud-native applications. Now, as you can tell, we are incredibly excited about Bergamo as well and the benefits it will bring to our cloud customers. So I'm happy to say that Bergamo is shipping in volume now to our hyperscale customers. Let me welcome Meta's Vice President of Infrastructure, Alexis Björlin, to the stage.
Hi, Lisa.
Alexis, it's so great to see you. Thank you so much for being here. Can you share a little bit about how we're working together?
Absolutely. So as you know, Meta and AMD have been collaborating on EPYC server design since 2019. These collaborations have been expanding over time with Milan, Genoa, and now Bergamo. We've worked closely to customize AMD's EPYC architecture to meet Meta's power efficiency and compute density requirements. We've also shared our learnings around reliability and maintenance and have helped improve the EPYC to server designs for all hyperscale deployments.
As one of the leading cloud companies, talk about Bergamo and how it fits into your plans.
Absolutely. We are incredibly excited to be preparing to deploy Bergamo as our next generation high-volume generative compute platform for Meta. We're seeing significant performance improvements with Bergamo over Milan on the order of 2.5 times.
I'm sorry, did you say 2.5 times?
I did. And it offers substantial TCO improvements over Milan as well. So you make it pretty easy on me, Lisa. We love products that make both our technologists and our business teams happy. So building upon the core silicon innovation that AMD has enabled with Bergamo, we've partnered with AMD to add several other optimizations that help our workloads, including dense compute chiplets, the core-to-cache ratios, power management, and manufacturing optimizations that help us pack a high number of these servers into a rack and deliver rack-level performance per TCO improvements as well. So with our focus on enabling new products for our customers as well as capital efficiency, we're thrilled to unlock the benefits of Bergamo for our entire family of apps.
Today, I'm super excited to be announcing the availability of 4th-gen EPYC processors with AMD 3D V-Cache, codenamed Genoa-X. We're delivering 4 new SKUs from 16 cores to 96 cores that are socket compatible with Genoa. Genoa-X helps unlock the potential of the world's most important and demanding workloads in technical computing. In blue, you see our highest core count Genoa-X processor. In gray, you see the top of stack Xeon processor. What this data shows is that across these applications, the 96-core Genoa-X processor delivers more than double the performance. And even when comparing processors with the same number of cores, the performance advantage remains very, very clear. So all this performance and software will be qualified on servers from the industry's top OEMs, and the platforms featuring Genoa-X will be available next quarter. I'd like to welcome Nidhi Chappell from Microsoft to the stage. Hey, Nidhi.
Thank you so much.
Thanks for joining us. So we have a strong partnership on technical compute across Azure, and I'd love for you to share with the audience about this partnership and our journey so far.
Yes, we've been on a mission together for some time now. So between Microsoft and AMD, we have a strong collaboration, and we have a joint goal. We wanted to make sure that we could deliver unprecedented performance for high-performance computing. We started our partnership back in 2019 with the introduction of our first HBVMs that featured first-gen EPYC processors. Last year, we announced that we would upgrade the third generation series with the AMD's 3D V-Cache, which provides 80% more performance for our customers at no additional cost. In just 4 years, we have delivered 4x performance for all of our HPC customers. Today, we are announcing the general availability of 4th generation of our HP series. And along with that, we have a new memory-optimized HPC virtual machines, which we are calling the Azure HX series. Now, both of our HB-V4 and our HX actually feature the AMD 3D V-Cache you were just talking about, and it also features that with our InfiniBand offering, which allows our HPC workloads to actually scale very well. Now, if you look at our 4th generation HB series, it offers 1.2 terabytes per second of memory bandwidth. You pair that up with the 2x improvements that we have seen in compute density, and now suddenly we can deliver 4.5x faster HPC workloads. This can be workloads like CFD, molecular dynamics, financial modeling, weather simulation, virtualized rendering of all sorts. And this is the beauty of actually combining the efficiency we get from AMD and the scale of cloud. That's on our HP V4. On the HX series, we are actually offering the ultra-low latencies, memory latencies, along with the 3D V-Cache, and a massive 1.4 terabytes of system cache. I want to talk about STMicro. So STMicro is a leading semiconductor company, and they are actually the first ones to use our Azure HX virtual series. Again, this is a brand new offering from us, and STMicro is going to use this for designing their next generation of chips. So a lot of their RTL simulations. Now, RTL simulations, especially as the process technology becomes deeper and deeper, requires much lower memory latency and large memory footprint, which is perfect for HX series. So what HX allowed STMicro to do is they were able to pack in a lot more of their simulation jobs in each VM, which in turn meant they needed fewer VMs, they could do it far more efficiently. With their recent experiments that they have done, STMicro has been able to save their simulation time down by 30%. So what that means is, their silicon engineers can actually look at a lot more design possibilities. They can improve product quality because they're now doing a lot more validation. But ultimately, they can bring products to market faster. And they don't have to worry about anything. They can do all of this in cloud because of our collaborations.
Another just great example of how we're partnering with our customers to deliver better solutions for our end customers. So VMs based on Genoa-X are now available with Microsoft's HP V4 and HX VMs, empowering companies to bring the most innovative products to market.
I'd like to bring on Jeff Marone of Citadel Securities to talk about their workload-optimized data center built with AMD. Jeff, welcome. Jeff, thanks for coming, and maybe you could tell us a little bit, first off, about Citadel and Citadel Securities.
Absolutely, Forrest. So Citadel is really two firms. First, we are the world's most profitable hedge fund, managing about $60 billion. But Citadel Securities is the world's largest market-making firm. So this is where I work and what I'm here to talk about. What does that mean? So as a market-making firm, we provide buyers and sellers, financial investors, opportunities to buy or sell any asset at a competitive price. And we do this at massive scale. So on any given day in the US equities market, 25% of shares that change hands pass through one of our systems. We do that for equities, options, ETFs, treasuries, and a variety of other assets at exchanges around the world. So now if you think about us from a technology perspective, it's best to think of us as real-time predictive analytics. We develop complex pricing models that predict where the market's going, sometimes to the millisecond or microsecond scale. And then as quickly as possible, we deliver those prices to the market. Now, there's really two technology platforms that underpin this business, two platforms with very, very different workloads. First, there's a computational research platform that we use to develop these strategies and test them. And then there's an ultra-low latency platform that we use to respond very quickly to buyers and sellers in the market. Underlying both of these platforms, there's a complex monitoring layer to make sure that those models are always performing safely and effectively in the market.
Tell us more about the research platform.
Yes, so let's talk about research. Research for us means developing hypotheses about where market prices are going, expressing those hypotheses in code, and then testing them. But here's the catch. Testing for us means releasing those strategies in a simulation of the entire market and seeing how they perform under a variety of different environments and scenarios. And so the compute platform that we need to do this demands enormous scalability and a real focus on workload optimization. So, as an example, all of this research, which runs in the public cloud, reaches a peak demand of about 1 million concurrent cores and relies on a market data archive of nearly 100 petabytes. In late 2020, we transitioned all of that workload to AMD and saw a 35% improvement in research performance. And so here is where EPYC's innovation, particularly in memory bandwidth, has truly unlocked a different level of performance for our business.
Tell us about the trading platform, because I think that's a little bit different story.
Very different, very different. So here's where we're vastly different. And I would say the polar opposite of many of the hyperscalers we heard from just a few minutes ago. So densification and virtualization are simply not welcome in this platform. And in fact, we invest massive resources internally and with AMD as our partner to take microseconds, nanoseconds, and soon picoseconds off our latency. And every one of the cores that run in this platform run in some of the most expensive data center real estate in the world. Expensive because it is as physically close as possible to the centers of financial markets. Right. So here is where our AMD partnership is also essential. If there is a packet of market data that is passing through that platform, it is guaranteed to go through a solar flare NIC. And for the most latency sensitive strategies that we run, Xilinx FPGAs are absolutely essential. Quite frankly, they bring to market strategies and models that otherwise would never see the light of day.
You know, Jeff, Citadel Securities is obviously a great example of the theme that we've been talking about, which is workload optimization and the need for workload optimized solutions. And you certainly have two very different problems.
Yeah, absolutely. And in research, we look very similar to a hyperscaler, but in low latency trading, we look about the opposite.
Right.
And AMD has done an excellent job of understanding complex, multifaceted customers like Citadel Securities. And I look forward to continuing to innovate on products that make a difference for our business and improve how financial markets function.
The Smart Switch. Developed with our partners at HPE Aruba, it's an innovative switch built on industry-standard switching silicon and AMD P4 DPUs. Traffic flows through the DPUs to deliver offload, infrastructure, and security services that provide the data center not just better efficiency, but enhanced security and observability. So putting it all together, you can deploy a few servers at a retail location with smart NICs providing security and manageability consistency to everyone. With Sienna EPYC CPUs providing transformative energy efficiency and performance, and Alveo Inference Accelerator cards powering latency-sensitive AI applications to enhance the retail experience and security. The full AMD portfolio can provide similar benefits to telco deployments, smart city applications, amongst many others.
Okay, so there's incredible interest in AI across the industry, and this is also, when we look at it, AI is really the defining technology that's shaping the next generation of computing, and frankly, it's AMD's largest and most strategic long-term growth opportunity. Now, in AI, we're focused on 3 key areas. First, it's delivering a broad portfolio of high-performance GPUs, CPUs, and adaptive computing solutions for AI training and inference, spanning across data center, edge, and intelligent endpoints. Second, it's developing an open and proven software platform to enable our AI hardware to be deployed broadly and easily. And third, it's really working with the industry, and it's expanding the deep and collaborative partnerships we have established to really enable the ecosystem to accelerate AI solutions at scale, because in this space, it's all about the ecosystem. Now, looking at where we're deployed today, it's really in many, many different places. So if you look at the edge, for example, NASA uses our leadership FPGAs on the Mars rovers to accelerate AI-based image detection. When you look at automotive, Daimler, Veoneer, Subaru, these are just some of our customers that are using AI silicon and software to power their driver assist and advanced safety features. In healthcare, leaders like Clarius are using AMD adaptive SoCs for faster AI-based imaging and solutions to really allow doctors to make quicker and more accurate diagnoses. And industrial, customers like ABB are using our technology for AI-assisted robotics. And earlier this year, we launched our Ryzen 7040 series CPUs, the industry's first x86 processors with a dedicated AI engine. And these have been ramping nicely, and we expect more than 70 Windows PC designs from the top OEMs to launch later this year, powered by Ryzen AI. And over the last 6 months or so, the broad adoption of generative AI with large language models has really taken this growth to a different level. AMD has been investing in the data center accelerator market for many, many years. And today, if you look at where we are, we power many of the fastest supercomputers in the world that are using AI to solve some of the world's biggest challenges. For example, at Oak Ridge National Labs, this is the #1 supercomputer in the world. It's the industry's first exascale supercomputer in Frontier. They're running large AI models on AMD Instinct GPUs to accelerate their cancer research. Let's just take a deeper look at how LuMi is using EPYC CPUs and Instinct accelerators for AI.
Cancer is one of the major burdens for human health. It takes a long time for the pathologist to go through one sample.
The aim of Combat AI is to build this decision support tool for pathologists to help them make the diagnosis. We show millions and millions of tissue samples taken from patients to this neural network. The more data you feed, the better the model becomes.
It takes a lot of compute to crunch that data and develop insights that we can use to advance humanity.
So the major challenges in analyzing these tissue images is, of course, a lot of this technical variation that arises from preparing these samples, like fixation and cutting and staining. And this, of course, poses challenges in training these neural networks. So with these AI-based decision support tools, we are able to provide pathologists with a tool for them to base the diagnosis on the data.
The supercomputer we built is going to help people to build more accurate and better models, get better outcomes.
We're impacting the lives of billions of people.
Now, to enable generative AI, you need both best-in-class hardware, but we also need a great software ecosystem. So let me now invite AMD President Victor Peng to the stage to share more about the growing software ecosystem for our AI solutions.
Thank you, Lisa. Good morning. It's really great to be here. I can sum up our direction and the current state of things right now and how we're enabling AI and software development with 3 words: open, proven, and ready. We've made really great progress in building a powerful software stack that works with the open ecosystem of models, libraries, frameworks, and tools. Our platforms are proven in deployments today, as you heard from Lisa, in Frontier and LuMi, these massive scaled-out operations. And the demand for our platform is simply gaining tremendous momentum, and we are ready to meet that. Realizing application performance really does require a leadership software stack optimized for the ecosystem. Let me first cover ROCm, which is the software stack we have for our Instinct data center GPUs. ROCm is a complete set of libraries, runtime, compilers, and tools needed to develop, run, and tune AI models and algorithms. a significant portion of ROCm stack is actually open. Our drivers, language runtime, tools like our debugger and profile, and our libraries are all open. ROCm also supports the AI software ecosystem, including open frameworks, models, and tools. Now, ROCm is actually in its 5th generation, and it includes a very comprehensive suite of optimizations for AI as well as high-performance computing. The ROCm stack includes tools that allow easy porting of existing software to AMD Instinct Platform. Now, this provides a very sound foundation for continued PyTorch and TensorFlow compliance, which enables a really rich out-of-the-box AI experience. So now let's move up the stack to frameworks, and specifically PyTorch, which is one of the most popular and growing framework. And what better person to do that than to have one of the founders of PyTorch talk about the collaboration AMD and PyTorch are doing to advance AI. So I'd like to introduce Sumit Katala to talk about PyTorch. So it's really great to see you. Thank you for coming.
Absolutely.
So why don't we start off by you giving us a high-level overview of PyTorch and the highlights of the latest iteration, PyTorch 2.0.
Sure thing. PyTorch is one of the more popular AI frameworks in the industry. It's used by several companies that you'd be familiar with. Meta, obviously, is one of its biggest users. There's OpenAI, Tesla. Almost like everyone in the industry probably uses PyTorch in some form if they're using AI. And PyTorch is the fundamental software through which most of the AI, like neural networks, training, and inference happens. And we recently released PyTorch 2.0, which builds a compiler that gives you speed-ups like about 50% to 100% faster over like the out-of-the-box PyTorch before. And it's powered by OpenAI Triton, the technology that Victor talked earlier. And we're pretty excited about it. We're seeing a lot of customers being super happy about it. And that's PyTorch for you.
So can you share some of your thoughts about the AMD and PyTorch collaboration?
For sure. The PyTorch and AMD collaboration goes way back, several years back. As Alexis, my colleague, talked earlier today, AMD and Meta have been collaborating in various forms, and PyTorch mostly came out of Meta. It's a multi-year collaboration. We've been giving AMD a lot of feedback on many aspects of the ideal hardware and software to run AI workloads, and AMD and us have been partnering together to build the ROCm stack and a bunch of PyTorch operators and integration to robustly test the whole stack. And I'm pretty excited for the current support, especially like on the Instinct accelerators that ROCm enables. And I'm pretty excited about MI300 as well.
So how do you see the collaboration that we're doing together benefiting the developer community?
Sure. Yeah, this generally like in AI workloads, one of the things we have is a single dominating vendor. And when you write your workloads, and you have to make them be supported by switching to a different hardware, there's a lot of work that goes into doing that. Like there's a lot of software work that developers have to do to move your neural network workloads from one platform to another. So one of the things that we've done with AMD, with the ROCm stack and the PyTorch integration, is you don't actually have to do that much work, or almost no work in a lot of cases, to go from one platform to the other. So developers, I think, are going to have a huge productivity boost as they try to switch to like the AMD backend of PyTorch versus like the TPU or like NVIDIA backend. And it's starting with the Instinct GPUs, and I'm hoping like you all enable it for like all of your other class of GPUs as well.
Absolutely. It's the goal to enable that capability to all the developers across all our platforms.
Yeah.
So thank you so much for the partnership. Really appreciate it.
For sure.
And look forward to more together.
Yeah.
Thank you. PyTorch 2.0 provides an open, performant, and productive option for developers to develop their latest AI inventions. We are one of only 2 GPU platforms that is integrated with PyTorch at this level. Okay, so we've covered ROCm and integration in open frameworks. That leads us to moving up to the top of the stack with AI models and algorithms. Hugging Face is the leading enabler of AI model innovation in the open source community. They offer an extremely wide range of models, including transformers that are at the heart of generative AI, but also vision models and models for all kinds of other applications and use cases. So here to talk to us more about their groundbreaking work and the partnership we have with Hugging Face is Clem Delange, CEO of Hugging Face. Please welcome Clem.
Hey, Victor. Hey, everyone.
Why don't we just start off and share your thoughts about why open source matters for the growth and the proliferation of AI?
Thanks for having me. So first, it's important to remember that most progress in AI in the past 5 to 10 years has been thanks to open science and open source. Maybe we would be 50 years away from where we are today without it. Now, when we look to the future, open science and open source AI are not only a way to accelerate technology, but also to level the playing field and distribute to all companies, startups, nonprofits, regulators, the tremendous power of AI, the tremendous value creation of AI, and the tremendous productivity gains, right? In the future, we want every single company to be able to train and run their ChatGPT on AMD hardware, right? And all of that allows companies to build AI themselves, right? Not just to use AI through APIs, for example. By doing so, most of the time with customized, specialized, smaller models, it makes AI faster, cheaper, and better to run. It also makes it safer for the companies, but also for the field in general, because it creates more opportunities for transparency and accountability, which fosters more ethical AI.
Can you share what the Hugging Face and AMD partnership is going to deliver?
So Hugging Face is lucky to have become the most used open platform for AI. Today we have 15,000 companies using our software, and they have shared over 500,000 open models, datasets, and demos. Like some you might have heard of, like Stable Diffusion, Falcon, Bloom, Starcoder, Music Gen that has just been released by Meta a few days ago. Over 5,000 new models were added just last week. Wow, 5,000 new models. I think it shows the crazy speed of the open source AI community these days. We will optimize all of that for AMD platforms, starting with Instinct GPUs, followed by Ryzen, EPYC, Radeon, embedded products like Versal and Alveos that we've heard about. We will also include AMD hardware in our regression tests for some of our most popular libraries like transformers and our CI/CD to ensure that new models like the 5,000 that have been added last week are natively optimized for AMD platforms.
So what are your thoughts on the benefit of our partnership that's going to provide to the developed community and really the whole industry as a whole?
Yes, so the goal is to really have the best combo between hardware and software, right? It's really important that hardware doesn't become some sort of the bottleneck or gatekeeper for AI when it develops. So what we're trying to do is to extend the range of options for AI builders, both for training and inference. I'm super excited in particular about the ability of AMD to power large language models in data centers, thanks to the memory capacity and the bandwidth advantage. Ultimately, AI is becoming the default to build all tech for all industries, right? From language models that we're talking about, but also image, audio, videos, right? We're seeing more and more time series, biology, chemistry, and many, many more domains. Hopefully, this collaboration will be one step, a great step, to democratize AI even further and improve everyone's life.
I think we all know that AI, the rate of innovation of this is unprecedented. The open source community is clearly a major driver of that rate and the breadth of innovation. And our software integration with and optimize for the open ecosystem to deliver a productive, performant, and open development stack is vital to that.
CDNA is the underlying architecture for our Instinct accelerators. It's designed specifically for AI and HPC workloads. CDNA 3 is our brand new architecture that uses a new compute engine, the latest data formats, 5 and 6 nanometer process technology, and the most advanced chiplet packaging technologies. I am super excited to show you, for the very first time, MI300X. Now, for those of you who are paying attention, you might see it looks very, very similar to MI300A, because basically we took 3 chiplets off and put 2 chiplets on, and we stacked more HBM3 memory. But what you see with MI300X is we truly designed this product for generative AI. It combines CDNA 3 with an industry-leading 192 gigabytes of HBM3 that delivers 5.2 terabytes per second of memory bandwidth, and it has 153 billion transistors across 12 5 nanometer and 6 nanometer chiplets. So I love this chip, by the way. Let's watch, for the first time ever, MI300X running Falcon on a single GPU accelerator. All right, let's start. We have to give the model a prompt. So we are here in San Francisco. Let's say, write a poem about San Francisco. Here we go, the poem's coming. You can see it's responding in real time. I'm not a great poet, I don't know about you guys. The city of dreams that always keeps you yearning for more. I would say that poem's pretty good, huh? It's the first time a large language model of this size can be run entirely in memory on a single GPU. And what that means is the infrastructure is also incredibly important, which is why I'm also excited to announce the AMD Instinct Platform. Let me wrap things up for today. We showed you a tremendous amount of new data center and AI technologies from our expanded portfolio of leadership EPYC server processors with Genoa, Bergamo, and Genoa-X, to our industry-leading DPUs and SmartNICs, to our expanding AI software ecosystem, and our next generation MI300X Datacenter AI accelerators. It is just an incredible pace of innovation, truly exciting. But what's more than that, we really appreciate the partnership with our partners, and a very, very special thank you to our partners who are here with us today: AWS, Meta, Microsoft, Citadel, PyTorch, and Hugging Face. We truly believe in co-development, co-innovation, and partnership. It's been a great day as we take another major step forward to make AMD the data center and AI partner of choice. Thank you so much for joining us.